Hi everyone, and welcome to this video introducing the Apollo runtime system. My name is Fedor. I have been the technical lead in the project where Apollo was developed, and I have also written the major part of its core source code. Now, in this video, I want to talk about the general purpose of Apollo. So I want to introduce what the system is and what it does. And I want to talk a little bit about its target audience. So basically, about the question, is Apollo interesting to you and what could you potentially use it for? In this video, we won't have any demonstrations, and also I won't be going too much into the details. So if you are interested in one of these aspects, I will provide links to other videos which have a more hands-on approach. In one of them will be a video which with really like the quick sequence of steps for you to get Apollo running on your system. And the other one will be a longer video series describing how you would actually orchestrate an application of your own using the Apollo system. And I will also provide the links to two of our papers where you really have like a more in-depth presentation of the system model, of the purpose, or what we want to do with it, and so on. Now, here we will have a rather more simple description of what Apollo is doing. So essentially, Apollo is a runtime system used for the orchestration of applications across cloud, edge, and IoT resources. It is a system which was developed at the University of Innsbruck by the Distributed and Parallel Systems group there. It is written more or less completely in Java, and it's completely open source. So it is completely available on GitHub, and you can see any details of what it's doing. And finally, it's intended to be used for research, teaching, or also if you have distributed applications which you want to run yourself. Now, this first point may be the one which is a little bit confusing if you are not from the area. So it basically says it's a runtime system for the orchestration of applications across cloud, edge, and IoT resources. So I just wanted to visualize this a little bit to explain what it means to orchestrate an application, or with other words, what a runtime system is doing. So you can imagine that the overall purpose of the system is in a situation where you have an application and you have some input data that you basically can execute the application with this input data. Now, what is an application? Well, an application is something that you want to do. It consists of individual tasks, and these tasks are connected in some way. So, for example, you have a sequence of steps, and this can be a sequence of tasks which you want to execute, or you have a more complex interrelation between your tasks. And on the other hand, you have some input data. The input data can mean that you have some input to a set of mathematical operations, or that you have some measurement, or that you have a sensor which gives you data, and so on. And now the thing where you would require a runtime system is a situation where you don't necessarily want to run this application on just your laptop. Maybe you can't do that. Maybe you have to maybe your application requires too much processing power, and then you have other resources available, and you could run these individual tasks on different parts of these resources. Now, how it's going to work with Apollo is that you will provide your application and your input data to Apollo, and Apollo will do what we call the orchestration of this application. And that basically means that it will, by communicating with these different resources, execute your application. So it will essentially place the task on different resources, and Apollo can interact with resources from AWS, from Google Cloud, from Azure, from other cloud providers on the one hand, so it can use cloud resources to execute your task, but it can also interact with locally present resources. You can execute functions on your own laptop in Docker containers. It can use OpenFast to execute them, for example, on Raspberry Pis, and we've also worked with executing them on Android devices. And after doing that, it will provide you the result, which is probably the ultimate goal of yours, since you just want to execute this application with some input and get the output. Now, more precisely, what does this orchestration mean? Well, on the one hand, it means that you actually coordinate between these tasks, because they have complex dependencies. For example, some tasks must wait for other tasks to produce their data. and some tasks are executed in parallel, or they're executed conditionally depending on the result of the previous task. And this is what Apollo does for your application. So it manages the data transmission between those different tasks, since they are placed on different resources, and it also enforces control and data flow. So it makes sure that, for example, the parallel parts of your application can be executed in parallel, that the conditional tasks are executed only if the appropriate results fulfill the condition, and so on. And the second part of the orchestration, which Apollo is doing, is it does this optimization. I mean, we've seen the slide before that you have different tasks, and then they can be placed on different resources. And that typically will result in different costs. In different amounts of money you have to pay for it, but also in different latencies. So some resources are faster, some resources are slower. And Apollo will optimize this deployment, so it will try to pick an optimal set of resources for your task, and it does that dynamically. Okay, now to the second part, who could the system be interesting for? So basically, the way I see it, there are more or less three groups of people that could be interested in using Apollo. On the one hand, same as us in Innsbruck, it can be researchers which operate in the domain of cloud edge applications. It could be someone who is teaching cloud computing or distributed systems, or it's also possible that you just have some application which is large, which is parallelizable, and which you would like to run in an efficient way because it exceeds the resources of your, say, laptop. So just to talk about each of these aspects a little bit. So the research aspect basically means you are researching cloud edge applications yourself. Maybe you even have your own runtime system. In that case, Apollo could be used as a benchmark or a baseline, so you could just compare it against what your runtime system is giving you. We really wanted to make Apollo as accessible as possible, so it's completely open source, and we also try to keep the dependencies relatively slim and to allow for a very easy build process. So as you will see in the demonstration video, it's actually very easy and very quick to deploy it on your machine. On the other hand, it's also possible that you maybe don't want to have your own runtime system because it's quite a lot of work to implement it, but instead you're, for example, working on scheduling approaches. And in that case, I know from experience, it can be quite hard even after you have developed your approach on paper and you are super sure that it works and it will perform well, it is difficult to come to the state of having, say, realistic experiments. And for that purpose, we basically also offer Apollo as a platform where you can just plug in your scheduling approach. So Apollo is from the start designed with an emphasis on modularity and flexibility so that you can on a very fine grain adjust any particular step that it's doing. It's not fixed on any particular scheduling, any particular transmission or routing approach, but instead you can exchange the way it does every single one of these things. And if you have some novel approach there, you can relatively easily take Apollo, adjust the behavior there, and run experiments to show how your novel approach performs against pre-existing approaches. If you're using Apollo for teaching, or rather if you are teaching courses on cloud computer or distributed systems, I think that Apollo could also be quite useful to you because it offers a visualization, a GUI where you can see what's happening. You can easily demonstrate different services of cloud providers, and in particular also how they compare to executing things locally. You could demonstrate the differences between different scheduling approaches, but you also could use Apollo as a platform for student projects where they, for example, have to develop the orchestration of some application, basically the same thing we will be doing in the tutorial series. And finally, it's also possible that you just have some application which is highly parallelizable and which you want to run. Now, of course, if you, for example, are doing something like a certain set of machine learning approaches, then it's very likely that you will have some specialized application for that purpose, such as Apache Spark. And in that case, if there's an existing application for your an existing platform for your kind of application, you of course don't want to be going for Apollo instead. But I think there's a certain combination of application qualities which could make Apollo interesting for you. And this is, for example, the case if you have an application where you have many different tasks and they are actually written in different programming languages because maybe you're using some pre-existing libraries. So this can, for example, be difficult to integrate in existing platforms which typically are based on the same language. On the other hand, if you, for example, also want to run your services on different providers or even a mix of providers of your laptop and of, for example, a set of Raspberries or something like that, then Apollo could also be interesting for you because it can do that. And finally, also if you have the situation that existing applications are not expressive enough in what you want to do with your application, you definitely should check out the language that Apollo uses to describe this application because as far as I'm concerned, I think you should be able to model any data and control flow in your tasks using AFCL. All right. So with that, I just want to briefly say what the next possible steps could be to get to know what Apollo can do better. One idea would be to look at the demonstration video that I talked about. So there you will see what the actual dependencies of Apollo are. So what you need to have installed on your computer to run it, how the build process looks, and this video is basically essentially really the shortest possible path between you sitting on your computer without any pre-installed things or anything and really having a running Apollo application there. And on the other hand, there's also a longer tutorial video. It's in fact a tutorial video series which shows you in multiple steps how you would go from having an idea of an application that you want to execute to really having it orchestrated. So we'll first look at how the input to Apollo looks like, then how you would generate an application description that Apollo can understand, how you would deploy the resources and describe how the individual tasks work, how Apollo then would orchestrate the application out of the box, and the last step, how you would modify the behavior if you, for example, wanted to schedule things differently. Okay, with that, I'm basically done. I hope it has sparked your interest in Apollo, and I would be happy to see you in one of the other videos. Bye.